Transformation of trigonometric functions, question 4. Sketch a cycle for each of the cosine function, state transformation from parent function. So these are all cosine functions for you. 3 of them are given here. I will do 2 and third one is for you to do. So the first one is a very easy one for me, cos of 2x. Well, let me share with you one important thing. In all the 3, we have horizontal stretch or compression or horizontal translation, right? So in question number 1 and 2, we had vertical stretch compressions or translations, and in question number 3 and 4, we had horizontal transformations for both sine and cosine. So question 3 was on sine, this one is on cosine. And I hope by the end of this video, you will understand all the transformations involved for sine and cosine at least, right? So let's do it for cos 2x. So we'll continue with our strategy, and that is working backwards. Now, cos 2x means there are no left or right or vertical things here. There's only one, which is the time period change. So the function shape remains same, and this is it. So we can draw our axis after drawing the graph. The center line is our x-axis going through the axis of symmetry. Right? So this is x value and that is y value for us. We have to draw one wave, so I have drawn one wave. If the question says 2 cycles, just draw 2 cycles and then work it out. Correct? As I said, it is sketch, not a graph. No need to make a table of values and write all values for x, right? And then so many points. We don't need them. Critical points are maximum, minimum and zeros. Right? In this particular case, zeros are easy, so we will incorporate them. The most important are amplitudes and time period. Now, since there is no vertical transformation, well, let's write down the transformation first. So the only transformation here is a horizontal compression by a factor of half. So we have horizontal compression by a factor of 1/2, correct? So that is the transformation. And what does that reflect? It reflects on time period, right? So instead of time period being 2 pi, it has become pi, or being 360 degrees, it is 180 degrees now. So that is what a major change is. So what I'm trying to say here is that this point has come to, instead of 360 to 180, I was going to write 360. 180 degrees, because in 2 pi periods we have 2 waves, right? And this means horizontally compressed. So one wave actually from 360 made it half, 180 degrees. That is how you could see it, right? So basically what has happened is that the time period has reduced, right? And maximum and minimum remains same, 1 and -1, correct? This is 180. Now these points, you know, is 90, and that is 45 for you, and that is 90 plus 45, which is 135 degrees, correct? As far as radians are concerned, so those of you working in radians will write pi for 180, pi by 2 here, right? And pi by 4, 2 pi by 4, 3 pi by 4 along the x-axis. So that becomes your sketch for cos of 2x. Now, Part B. Part B is same thing, that is, first thing is same, that is horizontally compressed by a factor of half. So that's same thing in short form. In addition to that, we have one more thing, and that is 30 degrees to which side? That is horizontal translation, right? Translation of 30 degrees towards left, to left. That is what it is. So basically what happens here is, so I'll draw on the same graph, correct? By now you're an expert, so you draw it independently. First you draw this graph and then shift it. So what you have to do is this is shifting by 30 degrees, that one is 45, and let us assume that this is 30 degrees for us. Let us assume the whole thing is 45 and this is 30 degrees. Let us assume that this is 30 degrees, okay? and that point is this. So these are our 30 degrees points. Let me draw these in blue, right? So let me say this is my 30 degrees here, and this is my 30 degrees ending here, correct? So these are my 30 degrees points. So I don't really have a graph paper to show you the correct thing, but I will use, my colored pens, and I already have a good line. So what I will do is, so these things shift by 30 degrees, right? So basically what is happening is this will also, this peak will 30 degrees shift. So we'll start from here, this point, and we will land not that place, but we will land here, 30 degrees less than 180 degrees. That means at 150 we are going to land. So our end point will be here at 150 degrees, correct? When you draw a new graph, you can do that. And it will start at minus 30 degrees. That is our first point, right? And so every point shifts 30 degrees to left, giving us a clear picture like this. So our wave basically will be coming like this, and let me draw like this, correct? And here it will go like this. Do you see that wave? That is the wave which is part B for us. This is part B for us. Do you see that? So amplitude remains same, which is 1, but the wave moves 30 degrees to left, and so it moves from minus 30 to 150, right? So that is your cos of 2x plus 30 degrees. I hope you understand that. Well, you'll soon come to know, because you have to do part C. In part C, however, there is no compression, but the wave stretches, and therefore the time period, instead of becoming lesser by 2, it becomes multiplied by 2. So we have a time period of 720 degrees, or 4 pi in this case, right? And 45 degrees it moves to the right. So 45 degrees it will move to the right, correct? So I'd like you to write down these transformation and sketch your graph. Okay? All the best. Thank you.